How much energy is needed to heat up an 8 kilogram block of ice from negative 30 degrees Celsius to 30 degrees Celsius?
Before we attempt to solve this problem, we have to look at this graph here. This has all the phase changes and all the temperature changes you need to get from ice to water vapor or steam, but we're only going to go through the first 3 in this problem. So first thing we have to do is we start from the negative 30 degrees Celsius, heat that ice up to 0, because that's where we need it to be. Then that's our first temp change. Then with the water and partially ice is our phase change, our first phase change. And then the last temperature change that we go through for this problem is when the water heats up to our 30 degrees Celsius. So what we're going to do first is, obviously like I said before, we're going to do the first temp change. So that's going to go from the negative 30 degrees Celsius to 0. So we use our equation, Q equals mc delta T, m being the mass, C being the specific heat of the ice, and delta T being the change in temperature. So we have our 8 kilograms placed in. 2100 joules per kilogram degree Celsius is the specific heat of ice, so we had to put that in the middle. And then 30 degrees Celsius is our change in temperature because we're going from negative 30 to 0. So our kilograms cancel out and our degrees Celsius cancel out, leaving us with joules, which is what we want. And we get 504,000 joules for our first temperature change.
So then you have to find the amount of energy is needed to change ice to water completely. So you're going to use your phase change equation, which is mass times the latent heat. So 8 kilograms is our mass, and the latent heat from ice to water is 3.33 times 10 to the 5th joules per kilogram. Our kilograms cancel out, leaving us with joules, which is the measure of energy, and you get
2,660,000. So after our phase change, now we have to go through our last temperature change, which is from the 0 degrees to the 30 degrees Celsius, which is the end temperature that we want. So we're going to use the same equation, the Q equals mc delta T from our first temperature change, plug in the 8 kilograms again, except this time for the specific heat, we're looking for the specific heat of water, not ice. So the number is different. It's 4,180 joules per kilogram degree Celsius. And then we're going to multiply that by 30 degrees Celsius again because we are increasing by 30 degrees Celsius. So we're going to cross out the Celsius and the kilograms because that leaves us with the joules that we need. And that leaves us with 1,003,200 joules.
So now that we've found the individual amounts of energy for each step to find our total energy, we need to add them all together. So you take the energy for the temperature change from negative 30 degrees Celsius to 0, the phase change from ice to water, and the temperature change from 0 to 30. So when you add up all of these numbers, you get this
4,171,200 joules. And that is the answer to our problem.